Okay, so we already covered balancing equations. Now we are going to cover limiting reagents in this section. Okay guys, so for limiting reagents, what you're trying to basically do is try to figure out which of your reactants will run out faster. So in these problems, I can tell you that you're gonna have to use a lot of the knowledge that you've gained from previous modules, like naming, writing formulas, calculating moles, writing and balancing equations, using your molar ratios, etc. So if you're a little rusty on these, I recommend that you go back to the modules and kind of study over that. So for a limiting reagent problem, I'd say there's basically three main steps to find the limiting reagent. So first of all, if they haven't given you a balanced equation, you have to write the balanced equation. Or let's say that they provide you with an equation, always make sure that it's balanced. Next is that if they give you grams, like they did here, you convert those grams to moles and then eventually use your molar ratio. And I wrote here coefficients, and right here I'm gonna explain why in a little bit. Okay, so first of all, I'm gonna write my equation up here. So copper to chloride reacts with sodium nitrate. Okay, and this is your typical double displacement. So remember these are gonna switch on the product side. So now you're gonna have copper to nitrate plus sodium chloride. Okay, so I'm just gonna write it here real quick and then I'll erase it. So remember, polyatomic ions, just leave them all together. So copper, we have one on each side. Chloride, we have two here, and we have one on the product side. Sodium, we have one and one. Nitrate, we have one and two. Okay, so for chloride, we can multiply the product side by 2. So it can give us 2. Okay, so we're going to put this coefficient here. Remember, it's also going to be multiplied by the sodium. So now you're going to have 2 sodiums. Okay, so we see that we have 2 sodiums and 2 nitrates on our product side, but right here on our reactant side we have 1. So we simply multiply each of these by 2, meaning that we just add a coefficient of 2 here. And then the others seem to be fine already, so we do not have to add, or I'm sorry, we do not have to multiply by anything else. Okay, so I'm going to erase this. Okay, so we already balanced the equation. So now we're going to convert grams to moles and then go to our molar ratio. So I'm going to start with copper to chloride. So I know that I have 13.58 grams of copper to chloride. Okay, so remember that you have to use the molar mass as a reference. So copper has a molar mass of about 134.5 grams per mole, okay? And this is going to give us a total of 0.181 moles, okay? So I'm just splitting everything in tiny steps so you can see. Okay, so once you converted the grams for one of your reactants to moles, you're gonna use a molar ratio of that reactant versus one of the products of your choice. So I'm gonna choose this one because if you notice here, I wrote like a second part to this question and it's asking me specifically for one of the products, which is sodium chloride. So I might as well just do this one instead. So our molar ratio, remember, is us looking at our coefficients and just writing them in this section. So per every 1 mole of copper 2 chloride, we're going to have 2 moles of sodium chloride. And this is going to give us an amount of 0.202 moles of sodium chloride. Okay, so now in order to determine the limiting reagent, you're going to do the same thing with this reactant. So we know that we have 23.45 grams of sodium nitrate. We know that per every mole we have a mass of 84.99 grams. Okay, and this is gonna give us a total of 0.276 moles of sodium nitrate. And now we're gonna go to our molar ratio. So we're gonna look at this coefficient. So per every 2 moles of sodium nitrate, we are gonna have 2 moles of sodium chloride. So this is actually a 1-to-1 ratio. And it's gonna give us the same number, 0.276 moles of this. Okay, so we're gonna see which one of these is a smaller number of product, or a smaller amount, I'm sorry, of product. So this is actually smaller than this one, right? So now we're gonna go back and look at which reactant it was, and we see that it was copper 2 chloride. So in this case, our limiting reagent is copper 2 chloride. Okay, so that's the answer for the first question right here. And now we're going to look at part B. How much sodium chloride can be produced? Okay, so now we are going to look at this part. And this is the total amount that we can produce in total before we run out of copper chloride. Okay, this cannot be it, because by the time we reach 0.202, we're already going to run out of our limiting reagent, so there's no way that we can reach this. Okay, so this is the maximum amount of this product in specific that we can create, and this is our limiting reagent. Okay, so I'm going to give you another problem. So this next problem says aluminum reacts with chlorine gas Cl2 to form aluminum chloride. How many grams of aluminum chloride could be produced from 26.4 grams of aluminum and 29.8 grams of chlorine gas? Which reactant is the excess reagent? So we have a 2-part problem here. I already listed the steps that you need to follow, and I already wrote the chemical equation. So you can pause the video right now and then come back to double check your answers. But in order for this to go a little bit faster, I'm just gonna write the coefficients already. And now I'm going to convert the grams that were given for each reactant to moles. So we know that aluminum is 26.9 grams. That gives us a total of 0.98 moles of aluminum. Then we have 29.8 grams of chlorine gas. So chlorine gas, or just chlorine, is actually one of the diatomic elements. So it comes in pairs. Okay, so you're gonna have 2 chlorines. Therefore, in 1 mole, and if you look at the periodic table, it tells you that the mass of chlorine is 35.45. But since this is a diatomic molecule, right here you're going to write 70.9 grams. Okay, and this should give you 0.42 moles of chlorine gas. So now we're going to look at the molar ratio. We're going to compare the coefficients for the specific reactant versus one of the products. In this case, we only have one product. So per every 2 moles of aluminum, as stated here, we are going to have 2 moles of aluminum chloride. So this is a 1-to-1 ratio, meaning that it's going to stay the same. So we're going to have 0.98 moles of aluminum chloride. And for chlorine gas, we know that per every 3 moles, we are going to need 2 moles of aluminum chloride. And this is going to give us a total of 0.28 moles of aluminum chloride. So you're going to have to look at both of these answers and determine which one is smaller. Okay, so in this case, this is smaller, right? So this means that the reactant that is going to be our limiting reagent is chlorine gas, right? Because it gives the smaller amount of product. So if our limiting reagent is chlorine gas, then that means that our excess reagent is going to be the other reactant that is left in this case, which is aluminum. So our excess is aluminum. Okay, so that's actually the second question. And the first question is asking us how many grams of aluminum chloride could be produced. So remember, the limiting reagent is the first thing that is going to run out. So actually, this is going to be the maximum amount that you can create of aluminum chloride before you run out of your limiting reagent. Okay, so this is the answer to number 1. This is the answer to number 2. And actually, I forgot to add this. So we have the answer in moles, right? But right here, the question is asking us to convert to grams. Okay, so what we're gonna do now is convert from moles to grams. So per every 1 mole, we know that aluminum chloride has a total mass of, just a second, 133.34 grams. Okay, so 133.34 grams per mole. And then once you multiply, you are going to have a total of 37.34 grams of aluminum chloride. Okay, so that's the maximum amount in grams of aluminum chloride that can be produced.